Hey everybody, welcome back to the channel. We're going to continue looking at the established laws of thermodynamics, part of Terrence Howard's book. If you're not caught up, you might be a little confused. I didn't want to spend too much time rambling on and on about this book like I did in my last video, but I did want to briefly review that what we're doing here is we're looking at a certain chapter of the book. I'm highlighting stuff that I agree with, or that is correct, stated correctly mathematically or scientifically, or just something I can get behind. Things that are incorrect, things that I disagree with, I am marking with pink highlighter. And then I've reserved this especially for Terrence Howard because he says a lot of things that are just confusing. Like they're not really correct or incorrect. They're just, you don't even know what he's trying to say. I want to address a couple other things that I kind of heard back from people. I'm going to get into this logical argument a little bit later, but someone was pointing out that this technically is not a contradiction, and I can get behind that because these don't completely contradict each other. You know, equals 2 versus greater than or equal to 2. But my main point was that he already proved 1 times 1 is exactly equal to 2, and then he came back and was like, oh no, it's at least 2 or greater than or equal to 2. Which, again, this wouldn't be as weird if it wasn't like just numbers. You know what I mean? If there were like any sort of variable involved at all that changed, this would make more sense to me because operations are, but binary operations are like functions, they're single valued. Meaning, I can't say 1 times 1 is sometimes equal to this. And then on a different day, I can say 1 times 1 is sometimes equal to this. Like 1 times 1 has to be just one number. It has to be single valued. That's something that's in the nature of functions and in the nature of binary operations. So this right here, this whole statement is just really weird to me. 1 times 1 has to be at least 2. So like sometimes it's 3, sometimes it's 4. Like what do you mean? Another thing from the last video I caught was I didn't highlight this green. I do agree that gravity is represented by numbers. Numbers are good for a lot of things, but yes, gravity is one of those things. Someone also pointed out this shouldn't have a negative sign, like the negative 9.8 meters per second squared. When I've done physical calculations, this as a vector, like the magnitude, I would always use it as negative because, you're getting pulled downward, you're accelerating downward. So yeah, like as a value, as a constant, I get that the acceleration due to gravity is not negative 9.8 meters per second squared, but when we do calculations, we normally use negative. We use the negative. But good catches. Oh, another one that I saw myself that I didn't even catch is right here. Again, possessive versus plural. Newton's third law of motion. Right there, it looks like it's saying like a multiple amount of newtons. He should have an apostrophe there to claim that it's possessive. It's Newton's third law. Okay, so I got to figure out where I left off here last. Mass is determined through a consideration of force. Okay, I'm going to say I disagree with that. Mass is determined by force? And then he cites F equals ma, which is that is Newton's second law. Again, he's on Newton's laws. I'm not sure why he says this is laws of thermodynamics, because he's talking almost entirely about Newton's laws, at least so far. But even that is a misstatement, because mass is not determined through force. This is saying force is determined through mass. This is basic. You can say, let's say it like this. Let's say force is a function of mass, right? Maybe I'm getting a little too mathy with it, but that's my background. Like if you have a certain mass, and say you have a constant acceleration. Well, if you change the mass, that's going to change the force, and you can determine force as a function of mass. So depending on the mass, that determines the force. He says depending on the force that determines the mass. Now maybe you could say something like, okay, if F equals ma is true, yeah, you could rearrange it, right, and say mass is equal to force over acceleration, right? You cancel these. So maybe you could say that mass is a function of force, but maybe I'm off base there. Somebody, someone, again, comments are open, folks. Comments are open. So is he correct in saying that mass is determined through a consideration of force? Maybe ignoring the word consideration of, because that's extra and that's stupid. But is mass determined through force, or is force determined through mass? Which one is the dependent and which one is the independent variable? For the physicists out there, I'd like to hear your opinion about that. Thank you. Nevertheless, if one mass times one mass equals only one mass, then there wouldn't be any such thing as the electrical effects that have been labeled as gravity to initially accumulate the matter into a mass. Oh my God. There's so much going on there. Okay. Wow. So, okay. Confusing. Confusing, right? One mass times one mass equals only one mass. What does that mean? What does that mean? Like, so, okay, let's skip that for a second. Electrical effects that have been labeled as gravity. That's very wrong. That's more of his electric universe, what is it, the theory of electric light orchestra. His theory of electric light orchestra. Yeah, that's if it's electric universe or electric sun model or whatever, that's debunked. To initially accumulate the matter into a mass. That is a weird thing to say. Weird. What does that mean? And then mass now is completely capitalized. Like every single letter is now capitalized. It's weird. I think he does it for emphasis. It actually came up one time in my comments because I was capitalizing words a lot, and someone thought I was like angry. And I'm like, no, I'm not angry. I was just trying to say that emphasizing a certain word instead of using something like italics, which is weird to do in a comment. I would just capitalize stuff. So I think he does capitalize stuff like based on emphasis. So, but accumulate matter into a mass. So matter's just, stuff. And it has a mass. Like mass is more of a property of matter, if I'm not mistaken. Right? Like something that is matter. It is matter, but it has mass. It's one of those is-a-has-a relationships. In fact, it would create the opposite effect of gravity, for every mass would effectively repel every other mass. Our entire universe would never come into fruition. So let's analyze that. This has to be incorrect, right? Our entire universe would never come into fruition. That has to be wrong, because here we are. Let me write that. Here we are, Terry. Let me write Terry. So you've basically debunked yourself. You're like, if this were true, our entire universe wouldn't even exist. Yet it does exist. So what is that? Modus tollens? Logically. If P, then Q, and if not Q, then not P. So your analysis here is incorrect, and you just proved that it's incorrect because we're here in our universe. Cool. I don't know what the link is here between gravity and electricity. I think I'll just write a note here like, gravity. Oh, snap. Hold up. Gravity is not electric. It's not electric. There's similarities in his stuff with the electric universe theory or electric sun. I don't know what it is. which is another just completely off the walls pseudoscience that's been completely debunked. So good job there, Terry. Therefore, in order for there to be an effect of gravity, I think that is misspelled. That one confuses me sometimes, I'm not going to lie. The effect with an A versus the effect with an E. Again, guys, comments are open. So is he using effect correctly there? I thought it would be effect with an E. He did he did this before with his what was it? What was it? Ensuring. Yeah, ensuring. Yes. At least 2. So again, now he's back to his 1 times 1 doesn't even equal 2. Like he's completely gone back on that argument because, and maybe if it seems like I'm making a big deal of it, mathematically, this is a big deal. Okay, equals versus greater than or equal to, or the word at least, that's a big deal. Like if you get that stuff, you can't just go around saying, oh yeah, 1 times 1 is exactly equal to 2 sometimes, but what this shows is that 1 times 1 has to be at least equal to 2. So I guess his other argument, looking at this mathematically, his other argument must also have to be, he's got to show that 1 times 1 is at most 2. Right? Think about that for a second. If he proved that 1 times 1 is greater than or equal to 2, and he showed that 1 times 1 is less than or equal to 2, that would imply that these two would logically imply that 1 times 1 must equal 2. Right? So if he says it has to be at least 2, he has to also prove that it has to be at most 2 if he's going to prove that it is exactly equal to 2. So let's see if he has any other arguments in this book that try to demonstrate that 1 times 1 is at most 2, not at least 2. Wow, and after just after I just debunked his argument logically, I even cited Modus Tollens on one of his. Now he has a section of his book called Pure Logic and Truth. Wow, Pure Logic and Truth. I would never write a mathematics book that had a section called Pure Logic and Truth. If we were going to go over some stuff in logic, sure, I would say, yes, this is about pure logic, but not about fundamental truth. That's more philosophical. All right, let's approach this problem from another logical perspective. Okay, I disagree with that because so far his stuff has not been logical, so you can't say another logical. By making the numbers 1 times 1 equal 1, we reduced the number 1 to a lesser value than 0. That is absolutely incorrect. Where's the proof for that? Where's the evidence for that? How can you go around making these outrageous claims? Okay, well he does say because. Let's see. Because 0 is the only digit, parentheses number, that when multiplied by itself, the sum could remain the same because the number doesn't really exist. It is a placeholder that holds no value. Okie-doke, a lot to go over there. So he says 0 is the only number that when multiplied by itself, the sum could remain the same. Okay, let's mark that as confusing. When multiplied by itself, the sum remains the same. When you multiply two numbers, that's called the product. When you add two numbers, it's called the sum. So he's mixing those two terms up here. Again, hearkening back to his main confusion between addition and multiplication. Almost this entire book is just how he confuses addition with multiplication, but in a lot of different ways, like we just pointed out. So the sum could remain the same. I'm assuming that he does, again, I mentioned this in part 2. I'm assuming he's talking about this. When you multiply it, it's equal to when you sum it, right? There are two numbers that do this. We demonstrated that in the previous video. I think I did it in my 1 times 1 fully debunked video, that the only solutions are a equals 0 or a equals 2. So 2 is also a number that when you add it to itself, it's equal to when you multiply it by itself. And the number 0 also does work for that. He's saying the number 0 doesn't exist. Now, let me point one thing out. I don't agree with anyone who ever says that a certain number doesn't exist. Because I personally don't believe that any numbers exist. I think that numbers are just abstract concepts representing quantity, rank, measurement, other things that we can describe in language to an extent, but also that we can describe better with numerical systems. Even imaginary numbers, the square root of -1, that has practical applications to electricity and stuff like that. The square root of 2 has practical applications to, again, architecture and using, especially in trigonometry, and if you use triangles for anything, you're going to get, irrational numbers because of Pythagorean theorem. It says the placeholder that holds no value. This is an argument that's come up before as well, that he doesn't believe, I don't think he thinks the number 0 exists, which again, let me get back to what I was saying. I don't think any number exists, for the record. The number 2 doesn't exist. The number 3 doesn't exist, but that's more of a philosophical point. That's just saying that they're not like here in physical space, that you can't go visit the number 3. It doesn't have a location, it's not tangible. So I don't say that any number doesn't exist. None of them exist, but they're just useful ways of describing stuff around us. 0 is actually very useful as a placeholder. It's great in our positional numbering system. In the decimal system, when you want, 1 quantity of 10 and 2 quantities of 1, that's like 1 times 10 plus 2 times 1. It's a positional numbering system, so if you do that, you get a value of 10 plus 2 units. But it's like if you have the number 10, that 0 is kind of working as a placeholder, I guess you could say, because when we normally count, we count 1, 2, 3, 4, but in certain, we call those the natural numbers, by the way. In certain computer science textbooks, they actually include the number 0 in the natural numbers, which I can get into a lot of arguments about, indexing beginning with the number 1 versus indexing beginning with the number 0, and there's jokes you can make about that in mathematicians versus computer scientists. Pretty funny. Anyway, 0 does work pretty well as a placeholder in positional numbering systems. Sure, even in binary. In binary, you got 0 and then 1 and then 1 0 and 1 1 and 1 0 0. It's very helpful in that matter, but it doesn't always represent the absence of value. That's a common misconception. If you have 0 apples, I don't know why it's always apples, but it's like, yeah, if you have 0 apples, or you could say, this actually helped somebody in my comments. They're like, well, what do you mean 0 times? Well, I'm like, think about like your inventory. If you're like in an RPG or something, and you have like 0 times broadsword, that means you don't have any broadswords left. 0 times apples, that means you have no apples. So that does represent the absence of value, or the absence of quantity. However, he's missing out on a lot of different ways that 0 is helpful besides just being a placeholder or representing absence of value. Since we're on the topic of thermodynamics, let's talk about temperature. Right? Our temperature scale, regardless if you're in Celsius or Fahrenheit, right? Let's say, let's say 32 degrees all the way to 212 is like the freezing and the boiling point of water in Fahrenheit. But then you get to 0 degrees Celsius up to 100 degrees Celsius. That's the freezing point of water and the boiling point of water. But you can still go below 0. Like you can, in fact, in the Fahrenheit scale, like often in our weather, it's like, oh look, it's like 10 below 0. So like people understand what it means when you say 10 below 0. It doesn't mean that 0 degrees you have no temperature. Okay, maybe an absolute 0, the third law of thermodynamics, maybe that's what that means. But in other numbering systems, we have 0. I mean, think about sea level. Sea level is measured 0 feet or 0 meters above or below, and then you can have negatives because you go below sea level, and you have positives, you go above sea level. So 0 exists, or I guess, like I said before, I don't think any numbers really exist, but 0 is a valid number to use. Terrence Howard has a lot of gripes with the number 0. I don't agree that it is not a valid number. It's a perfectly fine number. You can't divide by it. I get that, and he's mentioned that a couple of times before. He's upset that you can't divide by 0. At least not in the real number system. There's other number systems where you can divide by 0. Anyway, I'm kind of rambling. This is getting a little bit long. I'm going to have to divide this into parts. There's no way I can get through all of the established laws of thermodynamics in one sitting. No way possible. Anyway, once again, we're going to continue this. I do want to go through the entire chapter because, again, it was requested on my poll. People want to see it. They want to get my take on it. Want to hear me narrate. Which, by the way, Terrence Howard, if you're listening and if you're looking for someone to do the audio book, I'd be more than happy. I would like to do it blind. That way I can burst out laughing as I normally do when reading your stuff. But anyway, if you like that video, go ahead and give it a like. I am planning to continue this, but not right now. So please like, comment, and subscribe below. We'll see you in the next video. Take care of yourselves, everybody.